Okay, so converge or diverge. Notice there's integrals here. So we're going to be moving back into integrals with these. So I just wanted to remind you, it's been a while since you did this, that in the last test, this might have been a weak area for you. So let's go over this. If you see an integral that has an infinity or a negative infinity, right? The first really important step was to rewrite it as a limit and put the t going to infinity and put the t up here. Okay. Next, we've got to figure out how to do the integral. I can see that if I do a u substitution with u equal ln of x, I get the limit as t goes to infinity, 2 to t. The 3's just kind of carrying along for the ride. The 1 over x dx gets taken out with the du, and I get a 1 over u, putting the u in for the ln of x. So then I'm going to take the antiderivative. So I get 3 ln of u. And the important step of putting the x's back in, remember, because we're not going to change the limit. So ln of x here between 2 and t. So limit as t goes to infinity, ln of t, subtract ln of 2. Okay, so now I'm going to do the limit. Let t go to infinity, that's infinity. Ln of infinity, that's infinity. Infinity minus a number is infinity. So what do I get as an answer? If the integral equals infinity, that means the integral diverges. Okay, so here's another one. Converge or diverge. We've got this improper integral. Remember, that's what they're called, improper integrals. This very important first step of taking the infinity out of the limits of integration and put the t and rewrite it as a limit. And then this, I rewrote this and put the e in the numerator by making its exponent negative. Okay, so I can see I'm going to need a u substitution for this. So I'm going to let u equal negative x cubed, then du is negative 3x squared dx. So negative 1/3 du is x squared dx. So remember, I'm going to have to put that, put the x's back in, so be really careful that you carry everything along. So 1/3 e to the u du between 1 and t. So now I'm going to take the antiderivative, which is e to the u. I'm going to take the time to put the x's back in. E to the negative x cubed. And because I know I'm taking a limit, I'm going to take an extra step. And I'm going to rewrite that negative exponent term in the denominator. Now I'm going to plug in my limits of integration. So I have negative 1/3 e to the t cubed, subtract a negative 1/3 1 over e. All right, now let t go to infinity. T's going to infinity. This whole term will go to 0, and then I'll have 1 over 3e. So 1 over 3e, convergent. All right. Looking here, converge or diverge, again, limit with infinity. So I'm putting t up here, and I can see that I'm going to need a u substitution. So I'm going to let u equal 4x minus 1. Du is 4 dx. 1/4 du is dx. Okay, so I've got limit as t goes to infinity. 1/4, 1 over u squared du between 1 and t. So I'm going to rewrite this as u to the negative 2 so that I'm ready to take the antiderivative. So that's u to the negative 1 over negative 1. And I'm going to take the time to rewrite, put the negative out here, so negative 1/4. U to the negative 1, I'm going to write 1 over u, and I'm going to do two things at once here, and I'm going to put the u back in. Now I'm ready to plug in the limits of integration. So negative 1/4, 1 over 4t minus 1, subtract a negative 1/4, putting in the 1, so I get 4 minus 1, which is 3. So now I'm going to take the limit, let the t go to infinity. Infinity minus 1 is still infinity. 1 over infinity is 0. So I get 1/12. So since a limit is equal to a number, this integral converges.